As was said there, my name's Alison and I'm an associate professor in the Department of Psychology at Durham University. I'm going to start off, like I say, really talking a little bit about myself and my own background and my research. Then I will explain a little bit more about some other people's research. And at the end, there will be an option for question and answer session as well, using the chat function. Although I've been an academic, full-time academic in the Department of Psychology since 2010, I've actually been at Durham University for a lot longer than that. I began my undergraduate degree in psychology nearly 2 decades ago, and basically I never left. I completed my undergraduate degree, but then also went on to further postgraduate study, completing a master's and PhD in psychology as well. I then stayed and did some research positions before being offered a lectureship. My research interests are mainly associated with the neural basis of vision. So really that's to do with which bits of the brain are processing what it is that we see and how it is that we also interact with that. So how do we move our eyes around to try and locate items within a visual scene? I'm not only a sort of theoretical psychologist interested in those aspects. I actually consider myself to be an applied neuropsychologist. So I'm not, like I say, not only looking at those theoretical aspects of, well, which bits of the brain are doing what, but then trying to use that knowledge for some applied element. And for myself, that relates to then clinical applications. So that's to do with trying to understand ways in which we can help people who have impairments in, say, vision or visual attention as a consequence of some sort of brain injury. I've mainly focused on trying to develop rehabilitation tools to help people in those situations, but more recently, I've also started to explore trying to develop diagnostic tools. There's a rare condition called progressive supranuclear palsy, and it's really quite hard to differentiate from Parkinson's disease, especially in the early stages. So recently, we've been looking at trying to develop particular tasks based on this understanding of the visual system and eye movements to try and diagnose progressive supranuclear palsy in an early stage. At Durham, we focus a lot on research-led teaching, and that means that staff teaching modules, the modules they teach relate to their own areas of specialism. And one area I therefore teach is neuropsychology. So that's how do we know what bits of the brain are doing what? One way you can do this is by looking at people with brain injury. If you know where their brain damage is and the sorts of problems that they have, then you can use those 2 bits of information to make predictions about the roles of different areas of the brain with respect to what it is that they do. You may have encountered a classic case in neuropsychology called Phineas Gage. This is one example of a clinical neuropsychological case. Phineas Gage, he had an accident at work that resulted in a metal rod damaging his frontal lobe. As a consequence of which, people who knew him described him as becoming a different person. And that meant that people attribute frontal lobe areas to being responsible for personality. That's actually an oversimplification of what's going on, because the frontal lobes since then have been found to actually be responsible for lots of different elements. One example of this is to do with emotion regulation. And Phineas Gage was described as being very argumentative and quite frustrated and angry after his brain injury. And this matches up to lots of other cases now that we know about of people who have frontal lobe injuries. Someone who was previously quite a calm individual can become quite an angry person, very easily frustrated and flying off the handle at the smallest of things. And like I say, that's because the frontal lobe actually plays a role in regulating and controlling our emotions. If this also matches up to what we know from areas like developmental psychology. The frontal lobe is one of the regions which takes a very long time throughout our childhood and adolescence, and even early adulthood, to actually develop. And toddlers have particularly poor frontal lobe functioning. And they also have tantrums quite a lot about the smallest of things, like cutting their sandwich in the wrong direction. And again, they can't regulate their emotions. This is the way they wanted it. And when it's not like that, they sort of have this big tantrum because of their frontal lobe not being developed. But the frontal lobe is also involved in inhibiting behaviors. So individuals with frontal lobe damage will often just say the first thing that comes into their mind without thinking about the possible consequences of that. So very impulsive behaviors. And that's to do with the disinhibition that they're experiencing following frontal lobe impairments. But you can hopefully see how these sorts of things, like emotional regulation, like inhibiting actions, could look like somebody having a new personality. Another classic case within neuropsychology is the case of HM. HM had very severe epilepsy, and in an attempt to cure his epilepsy, he underwent surgery which removed part of his medial temporal lobe, including his hippocampus. After that surgery, he developed very severe amnesia, both for events that were preceding the surgery, but also in terms of learning and remembering new things since the surgery as well. And this provided very strong evidence for the role of the hippocampus in memory. Researchers at Durham University have been investigating the hippocampus, and very particularly Colin Lever and his colleagues recently discovered a new type of cell called a boundary vector cell within the hippocampus. And that's important for learning and remembering about objects, environments, and relative locations. But I'm mainly interested in vision. And so one of the classic case patients that I have worked with is an individual called DF. DF has visual agnosia, which is probably something which is a lot rarer than the others and you might not have heard of before. Visual agnosia means that the individual cannot recognize objects by sight alone. So if you were to present them with, say, a mug, they wouldn't be able to tell you what that object was unless they were allowed to use some other modality. So for example, if they're allowed to feel the object, then they can recognize the object via touch. But if it's purely by sight, they can't recognize the object. One of the things that I think is particularly interesting about cases of visual agnosia is that although their impairment is to do with recognition, they can actually still interact with the object pretty well. So if you do present them with a mug, they won't know what it is, but if they go to pick it up, they'll actually grasp it via the handle. So basically, the problem is to do with shape processing. And so we know that the patient, like DF and others with visual agnosia, have lesions that are indicated in this brain scan that you can hopefully see there, which is within an area called lateral occipital cortex. And so this tells us that lateral occipital cortex is responsible for this basic shape processing using vision. But then there's a different part of the brain that must be responsible for taking visual information and using it to guide actions like reaching and grasping. And this is called the sort of two visual pathways hypothesis, that there's one set of brain areas dealing purely with recognition and another set of brain areas dealing with using visual information for guiding action. Like I said earlier, I'm actually an applied neuropsychologist, so I try to use those sorts of understandings about how the brain is involved in psychological processes in order to improve functioning after some sort of brain injury like a stroke. Most of the patients that I work with have a condition that's relating to visual field loss. Very particularly, they have something called hemianopia. And hemianopia is a half loss of vision. It's not anything to do with their eyes, so they can see everything using their eyes, but the damage relates to the parts of the brain responsible for processing that visual information that's coming from the eyes. And so the way it then looks is that they have lost visual processing for one half of the visual field. Of course, the blind area isn't black, like it is in the picture here. Rather, it's the case that it's simply missing. So if we think about our normal visual field, I can't see behind myself, but I'm not aware of that. Most of the time, what I am aware of is simply the area that I can see. And the same is true then for individuals with hemianopia. They're not aware, it's not like there's a black hole in their visual field, rather it's that their visual field has just become much more restricted. And we've been developing a computer-based training to try and help people with this sort of partial visual field loss. It uses very simple tasks, such as the one that you can hopefully see on the screen here, this sort of odd one out task. You have to find the target item, which is defined by something like a different color. So here it would be finding the yellow one amongst the other red items. The tasks gradually get more difficult. For example, the item can move further away from the center of the screen, and it can be made more challenging by altering something like the colors. So the yellow and the red are very different, but pink and red are much harder to see, which makes the task harder. We can also speed it up. And by engaging with these sorts of tasks, the idea is that the individual would develop more efficient searching eye movements. Very particularly, their eye movements become larger and their eye movements have become faster. But they also become more organized, because one of the things that individuals with visual field defects struggle with is actually knowing where to move their eyes next. If you can only see one half of the visual field, you tend to just look within that part. So what we try and do with this training is encourage those eye movements in an organized, efficient manner to explore the parts of the visual field that are now blind. We've done clinical trials and demonstrated that this training can be effective. Our training is called Durham Reading and Exploration, or DREX, and our recent clinical trials have demonstrated significant improvements in things like visual search behavior. So that is how quickly and accurately individuals can explore their visual environment. And it doesn't seem to matter whether or not people are training using something like an iPad, so a touchscreen version of the app, or doing it on a computer using a mouse. Both seem to result in comparable improvements in this search and exploration performance. It also results in other meaningful improvements in quality of life. So here's an example from one individual. There's no doubt in my mind that I've learned to cope much better visually with the help of the training program. I can read and write much better. The program has taught me patience, given me confidence, and raised my self-esteem. So these are meaningful improvements then for individuals who, as a consequence of their visual impairment, often experience large difficulties in everyday life, going to the shops. They might often be bumping into things and knocking over items in the shop, bumping into other people. So exploring their environment can actually be very dangerous. Something like crossing the road, for example, if they don't do it very safely, then that could have dire consequences. But this sort of training then can actually improve those exploration and search skills, that improves their confidence in then going and doing those sorts of tasks, like actually going and doing the shopping. And this is one example of how the research that we're doing at Durham University is also having an impact on the well-being of the population. But I didn't just want to talk about my own research. I also want to give you a little bit of a taster of some of the other research that's happening in the department, so you can see the diversity of research interests and teaching that happens within the psychology department at Durham as well. Zane Clay is what we refer to as a comparative psychologist, meaning she researches great apes in order to investigate the evolutionary basis of behaviour. Her particular interest is in the development and evolution of social cognition, and that really relates to things like communication or empathy, social learning. So, for instance, she does observation work of great apes, typically bonobos, both in the wild and in captivity, and looks to see maybe under what situations the bonobos would help each other. So, is there evidence of altruistic behaviour in this alternative species? We have several researchers in the department who use electroencephalography, or EEG, which is a tool for recording the electrical activity within the brain. Holger Visa is one of the researchers doing this, and he particularly focuses on the brain activity associated with how we recognise faces. When we recognise faces, we're very good with familiar faces. So even if we really know someone, a family member, a close friend, even if you were to see a picture of them from a slightly different angle, something where they don't quite look their typical self to you, you would still be able to recognise them as being the same person because you're so familiar with what they look like. Whereas actually with unfamiliar faces, when they change orientation and look from a different angle, if you're presented with pictures of those, you're more inclined to say that they might actually be two different people because you're not so familiar with changing hairstyles, for instance. And he's been investigating the brain activity related to this and demonstrated that there is a significant difference in the brain activity that's elicited when we look at familiar faces as opposed to unfamiliar faces. And he's now exploring these changes and how they actually develop. At what point does a face become familiar to us, for instance? There are other researchers in the department that are also using various other neuroscientific techniques. So we don't just have EEG, but we also have functional magnetic resonance imaging to explore brain activity, as well as tools such as transcranial magnetic stimulation, which is a way of exploring how, if you change the activity of the brain, it would then modify behaviour. Virtual reality is becoming a more popular tool within psychology, and we do have various virtual reality labs in Durham. One of the reasons that they're so good is that you can actually start to explore behaviour in much more naturalistic situations. So rather than something happening purely in a laboratory, even though the VR is in a lab, the person starts to get a sense that they are in a different environment. This is an example of a virtual reality task that's been developed by Marco Nardini that's supposed to resemble something a little bit like air hockey. But what they're actually really doing with this task is combining sounds with the visual information that the participants get as well, trying to see whether or not you could use an auditory, a sound cue, to actually improve the accuracy with which somebody is able to then interact with a moving visual target. And this is going to have impact, again, for people with visual impairments and how they might navigate around the environment. Marco is also working with Laura Thaler, who's looking at echolocation. And so those sort of areas are coming together to try and figure out how people who are actually congenitally blind could use something like echolocation and maximize its effectiveness for exploring their environment safely. Others using virtual reality at Durham have been looking at things like what factors determine how close you get to another individual when you say walk down a corridor. or how you search around for objects in a very cluttered environment. And there's many more applications of virtual reality in psychology as well. Nadia Iceland is someone who focuses on fetal development. And she's using 4D ultrasound technology to explore lots of different questions. Some of these relate to maternal behaviour and how that impacts on the fetus. For instance, how does something like smoking in the mother affect movement of the fetus? Or how do fetuses respond to things like different light stimuli or sounds? So, for instance, if you play a sound to the fetus in the womb across the stomach, do they start moving their lips in response to the sound, which is actually the very beginnings of their development of speech. One of the other things is using an array of lights, an LED projection, again across the mother's stomach to the child in the womb, the fetus, and seeing whether or not they respond to that stimulus. So one of her recent studies looked at whether or not if you turn the LEDs so that they look like a very simple face, does the fetus look towards that more than just a random array of lights? And this relates to, because actually we know that newborn infants have a preference for looking at faces over other objects. And there's arguments that that is an innate ability, something that we're born with. And this really can tap into that further. If fetuses look more at face shape arrays as opposed to random arrays of lights, then this would really sort of help to confirm this idea that there is an innate preference for looking at faces. Nadia's also recently started to explore multiple pregnancies. Multiple pregnancies are a really unique opportunity to explore development of touch, because twins or triplets or more have extra touch sensation when they're in the womb. What you can actually see here in this picture, hopefully, are my twins and twin 1 with their arm wrapped around twin 2 in the womb. So normally, one child in the womb, they could feel their own face. You see examples of them sucking their thumb, for instance. But when there's more than one child in the womb, then there's a whole nother thing for them to touch and to learn about. So they can use these sorts of multiple births to explore the development of touch. We also have sports psychologists in the department. And this is an example here in the picture of our award-winning technician team. They're demonstrating a piece of research equipment that they developed for Dan Smith, who was doing some sport research with it. What the board does is it presents a series of lights sequentially, and then you have to record, or rather the equipment records, how quickly and accurately someone can push that sequence of lights. And so Dan's been exploring elements to do with speed within a sport setting and whether or not it can be affected by factors like motivation or by goal setting, as well as other things like stress or mood. But we don't just conduct research in laboratories. We also have researchers doing work in the real world scenarios as well. So one of the issues here is that the idling of cars when they're waiting in queues, such as at railroad crossings, can significantly affect the air pollution in the surrounding area. And here, hopefully on the left-hand image, you can see an example of a standard sign that's used to try and encourage drivers to turn off their engines at these sorts of junctions. So please switch off your engine when barriers are down to help improve air quality. And Julie van der Vyver has done some research where she changed the message that was presented on these signs and then looked to see how many cars actually turned off their engines. And she used various different messages. So one was based on a financial motivator. You throw your money away by leaving your engine on when the barriers are down. The second message was relating to health. Warning, pollution. When barriers are down, close vehicle windows. And the third message was more to do with sort of pro-social behaviour relating to kin. So think of the children. When barriers are down, switch off your engine. And what she found was that all three of these other messages significantly increased the number of cars that turned their engines off. So drivers were approximately twice as likely to turn off their engines in all of those experimental conditions relative to the control, the standard sign that's used. All messages, though, were sort of similar in terms of their effectiveness, showing that various different motivating messages can have a positive influence on behaviour in real-world scenarios. This is just a small selection of the research that's continuously being done by staff in the psychology department at Durham University. Hopefully it shows you the range of interests, skills and experiences of our academic body though. And also some of the types of projects that we encourage our students to get involved with as well. It also shows you how psychological research can be used to make a positive difference to people. If at any point you want to learn more about studying psychology at Durham, then please feel free to, contact us using the details that are provided here. You can also follow us on social media and get in touch with us that way as well. As I said, I've been at Durham my entire academic career since being a student, so hopefully I'm also well placed to answer a variety of questions that you might have, both about the psychology department and the university more generally. So like I say, there's options now. If you do have any questions, then please feel free to use the chat function here. Okay. Oh, could you share examples of application of virtual reality in psychology? So I'm going to go back to my own research here. So I've been using virtual reality over the past year or so to try and understand whether or not it could be a useful tool for individuals with visual impairment. So like I say, the tasks that we've been developing to try and improve their visual functioning after brain injury are very simplistic. They're looking for odd one out type tasks, but that aren't particularly naturalistic of the sorts of things we would do in a normal situation. I'm not often looking around my environment for a yellow X hidden amongst some red X's, but I am often looking around a table trying to find my keys or a pen or something like that. So what we can do in virtual reality much more easily is create these more naturalistic search tasks, but which are still standardized, which are still well controlled, which we can do repeatedly in a safe manner. So I wouldn't really want to encourage my patients to go out every day and practice crossing the road, because actually that's quite a dangerous situation if they get it wrong. But you could use virtual reality to encourage them to practice going up and down the street safely and potentially crossing the road as well. So that's one way in which I'm hoping to use virtual reality going forward to actually be able to explore this more and see whether or not it could have a rehabilitation application as well. Does anybody else have anything further?
Hello, Dr. Alison. I think we have another question. In the psychology program, do you also teach technology tools and application? I mean, you spoke about virtual reality and other tools and applications you've developed. So do you also teach computer-based programs and other things?
So we would have a variety of different opportunities for doing this. Within our research methods practicals, you would have opportunities to try out doing experiments. So this would give you the opportunity for potentially using some different tools such as this, depending on the practicals that you're involved with. You would learn to use different statistical programs for, again, analysing data as part of research projects. And then in your dissertation, you have to, in your third year, all students would do a dissertation project, which is something where you work with a supervisor, normally with one other student as well, to design your own research project and then conduct that, report it, and it's worth 40 credits, so a third of your final year mark. And that means that because of our diverse research interests across the whole of the academic body, there's hopefully opportunities for finding a supervisor who would work in the sorts of areas that you're interested in. And then you can design an experiment, a study, that would use one of these different tools if that's what you were interested in using. So I know that Holger Visa, for instance, he has had students using EEG to do their dissertations, and others in the past couple of years have started to use virtual reality as well. I remember someone who was using virtual reality to look at phantom limb syndrome. So I don't know, again, if you know much about phantom limbs. If you were to place a pretend arm, normally this is sort of a rubber hand illusion. So placing a pretend arm in front of somebody and then hiding their own arm underneath a table. If you interact with the rubber arm, then the person actually feels like it's their own hand. And so you can do more complex experiments like this within virtual reality. There's also opportunities throughout the degree to become what we refer to as a research assistant. So this is very particularly, we have a research assistant scheme in the second year. The students who are interested can sign up to work as a research assistant with a member of staff. So if you were interested in, for example, virtual reality or using transcranial magnetic stimulation or fetal scanning or whatever it was, then you could sign up to work with that researcher and get more hands-on experience using those sorts of tools to help with their ongoing research as well.
Thank you, Dr. Alison. I mean, I think that's a great piece of information that you've shared, that even at an undergraduate level, do you mean a student can actually work in research projects with professors and be part of their teams?
Absolutely. This is, in the second year of undergraduate study, you can sign up to do that. And often then, once they've done it in the second year, they might use that same experience as part of their dissertation. So they might learn some skills as part of their research assistantship and then think, oh, that was quite fun, I'll do that for my dissertation as well. Or they could go off and do a dissertation and learn another technique with another member of staff. Or you can continue on with the research assistantship, often in the third year as well.
Okay, I had a question on this, and I'm very curious because a lot of students try to do a double major, doctor. So what are the typical combinations now? I mean, are people actually taking up technical programs such as information systems or IT along with, or say marketing along with psychology? Because then it becomes far more useful to get a job later. Is that something that you're seeing often?
We don't see it very often. We do have these joint honours programs. Our main ones are actually psychology and education. I think that's where we get a lot of students so far. Philosophy and psychology is a relatively common one as well. Okay. The others generally fall within what we call natural sciences, so that it's actually not a pre-specified, you have to take computer science and psychology, but rather you have the option to take modules across anywhere within the science faculty, if you like. So you could choose to do a physics module, a chemistry module, and 3 psychology modules, or build it up that sort of way. That's, natural science programs.
Okay, because I've seen a lot of interest towards the consumer behavior side, and a lot of students now choose, also think in terms of skills which might not just lead to a career in academics, but also maybe a corporate career. And so they start looking at other subjects that they can combine so that they're more employable. Cases that they have interest there.
you can actually still do this within natural sciences.
Okay.
There are actually modules that are business modules, I think, within the natural science program.
Okay.
On the natural sciences webpage for Durham University, it lists all of the possible combinations that can be done. We also have, there's optional modules within criminology. So for anyone was interested in sort of forensic psychology, they can choose those. And I think if anyone particularly had a sort of more business interest, then the behavioral science program might be a better fit than pure psychology, because in the third year, they have lots of electives that would feed into this idea of kind of organizational and occupational psychology.
Okay, thank you so much, because a lot of, we just had another panel discussion where the panelists spoke about behavior psychology and its role in actually deciding communication to your audiences. I mean, you're trying to build a personal brand, knowing psychology is, I mean, I was pretty surprised to see that. So it's great we're having a session on psychology right after that. And thank you for the overview you've provided.
No problem at all. I'm, like I say, happy to help. So thank you very much for inviting me along.
Okay. So any questions the audience have? You can please type the questions on the chat here. Okay. I think our audience have had their questions answered. So anything else you'd like to say, Dr. Alison?
No, like I say, really the main thing is that, you know, feel free to explore more on our websites and follow us on social media if you're interested to learn more. You can get in touch with us anytime, and we're always happy to answer questions.
Thank you so much, Doctor, and great to have you on a session. And thank you, audience. And we have another session coming up at 3:40 India time. So tune in for getting global updates and have all your questions answered about your global ed aspirations. So see you on the other side again at 3:40. Okay, thank you, Doctor. Great having you here. Thank you.
Thank you very much, everybody. Nice to have you.
Thank you.
Bye.